Hello again. I'm taking one another example on evaluation of double integration over a region. In this example, we are going to evaluate double integration x square dx dy over the region R, where R is the region in the first quadrant bounded by the curves xy is equal to a square and the line x is equal to 2a, y is equal to 0 and y is equal to x. So now first we have to look for the curves which are bounding that region. The curve given to us xy is equal to a square is rectangular hyperbola. The another curve is x is equal to 2a. There's the line parallel to y-axis. Then y is equal to 0. This is x-axis. Then y is equal to x. The line passing from origin having slope pi by 4. So if we plot all of them, the rectangular hyperbola xy is equal to a square has got two parts. One part is this in the first quadrant, another part in the third quadrant. But since they are saying into the question itself that we have to be in the first quadrant, therefore we are going to consider only first quadrant part. Now this rectangular hyperbola is xy is equal to a square. Now y is equal to 0 is our x-axis. Y is equal to x is the line passing from the origin having slope 45 degree. So this is the line y is equal to x. Now I have to draw this curve x is equal to 2a. I have not plotted this. X is equal to 2a will be line parallel to y-axis. I do not know it will pass from this point, it will pass afterward, it will pass before. So before plotting this x is equal to 2a, I should calculate what is the coordinate of this point so that I can judge from where this x is equal to 2a will pass. And to find the point of coordinate of these 2 points are the intersection of the curve y is equal to x and xy is equal to a square. So we can solve these two equations simultaneously. I can put in place of y x over here. So this will become x square is equal to a square. So x is plus minus a. And if I put x is plus minus a in the equation of the line y is equal to x, then y will be also equal to plus minus a. So the point of intersection is a comma a and minus a comma minus a. So this point will be definitely a comma a and this will be minus a comma minus a. Since we have to focus on the first quadrant, so I'll be taking now this point have x coordinate a, so x is equal to 2a will be right of it. So definitely the line x is equal to 2a. If I plot, I'll plot from here. There's the line x is equal to 2a. Now the reason which is given to us is bounded by all these four curves. So rectangular hyperbola, line y is equal to x, line x is equal to 2a and y is equal to 0. This is the reason which I am getting, which is bounded by all these four, on which I have to do the integration. Now this reason is interesting. Why it is interesting? Because in this reason, if I take a horizontal strip, suppose I take a horizontal strip, I'm making it by a dotted points. So the horizontal strip here, this will go from x is equal to this line to x is equal to this vertical line. and that horizontal strip in this region will go from x is equal to this slant line to rectangular hyperbola. That means the region will be divided into two parts. Below this line there will be one region, below above this line there will be another region, because here the limit of this strip will be different, here the limit of this strip will be different. So what we can do, we can solve the integral in this region as well as in this region and add it. Okay, if we take vertical strip, the problem is not going to be resolved. It will be again in two part. The region will be divided into two part from this line. Here my vertical strip will start from this horizontal line goes to this slant line, and in this region my vertical strip will start from the horizontal line and goes to the rectangular hyperbola. So I take horizontal strip or I take vertical strip, ultimately I have to do the integration in two regions. I'm representing those region by region R1 and R2. R1 and R2 combined represent the region R which is given in the problem. Now if I'm writing now my integral for R1, okay, so my strip starts from, I have taken vertical strip, so strip starts from y is equal to 0 line, goes to y is, what is y on the slant line? The equation of the line is y is equal to x, so y on the slant line is y is equal to x, and that will move from x is equal to 0 to x is equal to a, and the function is x square dx dy plus, now for the reason R2, my vertical strip starts from y is equal to 0, goes to y is equal to, on the rectangular hyperbola, y is a square by x, and x goes from this point, x is a, and it goes to a to this point. This point has x is 2a, so it will be going from a to 2a, so a to 2a, x square dx dy. Now if we try to solve the integral, the first integral is 0 to a. Since I'll be integrating first with y, as this is the limit of y, first I'll be integrating with y, so only dy is there in the function. Its integration will be y 0 to x, x square dx plus a to 2a. Again here also I'll be integrating first with y. It is 0 to a square by x, x square dx. Now this leads to, if I substitute 0 to a, 0 to a, x, x square dx, a to 2a, a square by x, x square dx. So this will be 0 to a, x cube dx, and a square out, a to 2a, this will be x dx. That leads to x raised to 4 by 4, 0 to a square, x square by 2, a to 2a. So it is a raised to 4 by 4, a square by 2, 4a square minus a square. So a raised to 4 by 4 plus 3a raised to 4 by 2, that is 7 by 4 a raised to 4. That's the answer. Thank you.